एवरीवन वेलकम बैक इन माय ऑफिशियल यूट्यूब चैनल एग्रीकल्चर वर्सिटी। एक बार फिर आप सभी का मैं स्वागत करता हूं, हार्दिक अभिनंदन करता हूं अपने यूट्यूब चैनल एग्रीकल्चर वर्सिटी में। सो टुडे वी विल स्टार्ट द वीट पार्ट 3। सो लास्ट टाइम वी हैव डिस्कस्ड द botanical description of wheat. So after that we will start cultivation practices of wheat cultivation. So from the climatic conditions and up to harvesting of this crops, we will discuss today in part 3 of the wheat cultivation session. So without any delay, let's start that wheat cultivation. Part first, we have discussed about that wheat cultivation. And in part first, we have completed some very important portion from that introduction of wheat. And after introduction, the economic importance we have completed with that area and distribution. So that according to the USDA government data, whatever the current update is here, so we have completed area and distribution on that current update basis. What the wheat growing zones of India already discussed in part first. You must watch classification of Indian wheats. And in second part, we have discussed about botanical description. So after that botanical description, we will discuss that in part third. Let's start from that climatic requirements. So from the climatic requirements, so as we know that wheat crop, winter season crop. So as usual, it's required the cool temperature, cool weather. So the best wheat are produced in areas favored with cool, moist weather during the major portion of the growing period, followed by dry, warm weather to enable the grain to ripen properly. The optimum temperature range for ideal germination of wheat seed is 20 to 25 degrees Celsius. So the seeds can germinate in the temperature range 3.5 to 35 degrees Celsius. So 3.5 here, the minimum range of the temperature, and 35 is the maximum range of temperature, because in winter season, so the 35 is enough. And for that maturity time, at the time of maturity, it's required at higher temperature. At the time of germination, it's required at average temperature. But during growth, is required at very lowest temperature and very short duration of the light. Wheat plant requires about 14 to 15 degrees Celsius optimum average temperature at the time of ripening. And the temperature condition at the time of grain filling and development are very crucial for yield. Temperatures above 25 degrees Celsius during this period tend to depress grain weight. Means at the time of grain filling, at the time of growth, if the temperature higher than 25 degrees Celsius, so that will be the reason of depressed grain weight. The next is according to the state, the climatic requirements. So at the time of germination, it requires 20 to 25 degrees Celsius. And at the time of stage of tillering, 15 to 16 degrees Celsius, accelerated growth, 20 to 23 degrees Celsius, proper grain filling, 23 to 25 degrees Celsius, and at the time of ripening, 25 to 30 degrees Celsius is required. So after that climatic conditions, let's discuss about the soil, which type of soil is required and good for the cultivation of wheat crop. So here is given that soil, wheat is grown in a varieties of soil in India. But the important is that if clay loam or loamy texture soil, so that is very best and suitable soil for wheat cultivation. Good structure and moderate water holding capacity are ideal for wheat cultivation. Care should be taken to avoid very porous and excessively drained soils. And soils should be neutral in its reaction. In India, the wheat growing areas can be mainly divided into 5 soil divisions, and the divisions are: the first, the Gangetic alluvium of Uttar Pradesh and Bihar; second, the Indus alluvium of the Punjab and Haryana; the black soil regions of central and southern India, comprising Madhya Pradesh and parts of Maharashtra and Karnataka; the hilly regions of the Himalaya and elsewhere; the desert soil of Rajasthan. So when in part first, we have already discussed the zones, wheat cultivation zones in India. So there are different regions, different types of soils are found, and in different types of soils, we have grown that wheat cultivation. But preferably soil is that clay loam or loam textures with good structure and moderate water holding capacity are ideal for wheat cultivation. I repeat again. So let's move on the soil preparation. After the selection of soil, let's come on the heading of soil preparation. So wheat crop requires a well pulverized but compact seed bed for good and uniform germination. with 3 to 4 plantings. Repeated harrowing, cultivation and planting before sowing to produce firm seedbed are considered desirable for raising a good crop of wheat. In the black cotton soil, blade harrow is used instead of the plow. For field preparation, 1 to 3 ploughings with an iron plow may sometimes precede the use of harrow, blade harrow. So pre-sowing irrigation of field followed by cultivation of planking to prepare a fine well pulverized seed bed. And recently, zero tillage and minimum tillage sowing practices using a specially designed zero till seeding cum fertilizer drill have been recommended to save the time required to prepare proper seed bed under the rice wheat rotation. Other forms of resource conservation technologies, which is known as RCTs. Okay, so resource conservation technologies, which are also gaining momentum, include rotary tillage and furrow irrigated based technology. So as we are aware now, in that nowadays cultivation generally uses rotavator, that is known as rotary tillage, okay, and furrow irrigated based system of technology. Okay, so that all are the part resource conservation technologies. Okay, the rotary tillage technology saves about 80% diesel, but has given the higher yields over zero tillage as well as conventional tillage. Recently, new machines like turbo seeders, rotary disc drill have been fabricated to seed into surface retained crop residues, which is otherwise being burned, causing environmental pollution and loss of essential plant nutrients. So after the discussion of soil preparation, now let's discuss about the varieties. So according to the zones, according to the time, the different types of varieties is given here on the basis of zones. So first, Northern Hills zone. So it is given that PSIR high fertility, PSRF low fertility, ESRF low fertility, LSRI medium fertility, and high altitude areas. So it's given according to the different type of soil fertility, different type of areas. So according the variety is given accordingly. So TS means timely sown here, and IR denoted to irrigated. So timely sown irrigated high fertility region, the HPW 349, HS 507, VL 907, VL 804, VL 738, and also given here yield. So what is the range and what is the average yield is given by that particular varieties and particular region. Okay, so 37.5 and 42.5, that is the range to production of these varieties, but the average yield is got at 40.5 quintal per hectare. So next one, timely sown rainfed low fertility. RF means rainfed condition, low fertility soils. So is there given that variety HPW 349, HS 507, VL 907, SKW 196, VL 804, VL 738, TL 2969, and TL 2942. So the average yield is that 27.5 to 31.4, and the average yield is that 29.3. Early sown rainfed low fertility condition, given that variety, and after that late sown rainfed irrigation medium fertility. In medium fertility soil is given, and high altitude areas. So for that high altitude areas, VL at 32, HS 375 variety is given. After that, for the northwestern plains zone, northeastern plains zones, central zones. So these are the varieties is given front of that zones according to the high fertility, medium fertility, late sown, and earlier sown. Okay. So according to the zone, that varieties is given, the lot of varieties of given, you can check here and study here. And according to your zones, according to your area, you can select that varieties. And the average yield and the average yield is also given, and range is also given of that harvesting area, means total production of the area. Next is peninsular zone, southern hills zone, and marginal areas. So marginal areas means for the salinity and alkalinity conditions, means where the higher pH range is found up to 7.5, up to 8, or up to 8.5. So in that region, we can easily grow that KRL 210, KRL 213, and KRL 19 varieties. So these are especially recommended for that salinity and alkalinity conditions. Now the next heading is seed and sowing. So the first discuss about selection of seed. How to select that seed for that good crop. Selection of seed, only healthy seeds of right variety suitable for a particular locality should be selected for sowing. And there should not be any mixture of seeds or other varieties of weeds. And the seed should be purchased from a reliable sources, always use certified seed. If seed is not treated, so treat with Vitavax Thiram 2.5 gram per kilogram of seed. So seed treatment is very important. If already purchased seed means certified seed is treated, that is very good. And if seed is not treated, so we have to treat with that seeds Vitavax and Thiram. Okay, that is protect our seeds, seed-borne diseases, some soil-borne diseases, and all types of fungal diseases. So seed treatment is very important before the sowing of seeds. So that is talk about selection of seed, and next we will talk about the sowing techniques. So we have generally 4 types of sowing techniques. We prefer that. The first is drilling. So in this method, seed is sown by seed drill or fertile seed cum drill. So with the help of this implement, seed drops at uniform depth and results in uniform germination and regular stand. Seedbed should be fine and well leveled, free from clots and weeds for the use of seed drill or fertile seed drill. The second is behind local plow. This method consists of dropping the seeds by hand into the furrows that have been opened. The local plow, when seeds is dropped in furrows by hand, it is called Kira method. And when it is dropped through a pora or nai or hazara, a special attachment with local and desi plow, it calls pora method. In this method, seeds are dropped at a depth of 5 to 6 centimeter and germination is satisfactory. The next third is dibbling method, and this method is used in case where supply of seed is very limited. So sowing is done with the help of a small implement known as dibbler. Dibbler, it is a wooden or iron frame with pegs, and the frame is pressed in the field and lifted, and then 1 or 2 seeds are dropped by hand in each of the hole. It is not a common method because it's a very time-consuming process. So for the trial of the crop, for that smallest area, we can easily use that dibbler. We can easily use the dibbling methods. And if we have very less amount of seeds, because this is newly released varieties and we cannot get in reliable amount, so in that case, we can use the dibbler method. The number 4, broadcast method. So in this method, the seeds are broadcast and then worked in by harrowing in order to cover them. However, the seeds are not uniformly distributed in the field. This method of sowing is very insufficient and should not be encouraged. The germination of broadcast seed is relatively poor and the plant stand is often irregular. Wastage of seed also results because most of the seeds is left on the surface where they cannot germinate and may therefore be picked up and eaten by birds. So these are the 4 methods to generally sowing of this crop. But in the nowadays, where we are talking about that resource conservation technologies, RCTs, because we don't want to waste our crop residues, which releases from the previously crops or left in our field. Okay, so we also want to use and also want to make that part of the soil fertility without any wastage, without any burns of soil crop residues. So in that case, the different types of techniques we have, and that is with the protection of the resource, with the conserve of the resource, which technologies are adopted to sow this crop. So that is known as resource conservation technologies. So in that some methods are come like this laser and leveling. So this is precursor resource conservation technologies that is a must for the proper implementation of other RCTs for greater productivity and profitability. This technology increases the productivity, increases area under crop, saves water and other inputs, enhances factor productivity and reduces cost of production. The surface seeding. So this RCT is specifically suited to single crop DR lands of eastern parts of India where soil remains wet after rice harvesting. The technology requires no tillage, broadcast, dry or soaked seed under saturated conditions. The scope in areas where soil remains wet after rice harvesting and doubles the cropping intensity. Now the third is zero tillage, and that is very important practice, zero tillage in resource conservation technologies, which is generally followed in nowadays. The main feature of the technology are zero tillage. Drill is simple and affordable. Direct drilling in untilled condition advances sowing time, realizing higher yields, saves more than 90% fuel energy and time. Similar yield at lower cost in comparison to timely sown wheat with conventional tillage and better management of herbicide resistance by types of failure is minor. Number 4 is bed planting. The flow irrigated raised bed system accommodate 2 to 3 rows of wheat on raised bed with 75 to 90 centimeter spacing between beds. The flows in between the beds are used for irrigation purpose, and the method helps in saving of water up to 40% without loss of yield. There is the FIRB techniques, which is known as flow irrigated raised bed system. Seed rate and spacing. So a seed rate of 100 kg per hectare is sufficient under favorable conditions of normal sowing, timely sown irrigated condition. For varieties with bold grains and under late sown condition, seed rate should be increased to 125 kg per hectare. In case where wheat is to be shown by dibbler, a seed rate is only 25 to 30 kg per hectare will be used. And for normal sown crop, a spacing of 22 centimeter between rows is recommended. When sowing is delayed, a closer spacing of 15 to 18 centimeter should be adopted. So line to line spacing 22 centimeter, and that is generally understood. In wheat crops, the plant will be sown plant to plant distance 10 centimeter is enough, and it will be also vary according to the varieties, because how many tillers will produce by one seeds, it will be depend on it. Now, zone-wise sowing time, seed rate, and fertilizer dose is also given. After that, we will study that manures and fertilizer, what amount is required, but also given here the dose of recommended fertilizers. So, according to the zone, North Hill zone, the sowing condition is irrigated timely sown. So, timely sown, that is a period of 1 to 15 November. Okay, means first fortnight of November is given the timely sown. If we talk about the late sowing condition, so after 25th of November, that is the late sowing condition. So normal seed rate is 100 kg per hectare, we have already discussed. And in late condition, the seed rate, the 25% will increase the 125 kg per hectare. The fertilizer dose is required at 120, 60, 40, whereas 120 nitrogen, 60 kg per hectare phosphorus, and 40 kg potash per hectare is required. And the giving method is very simple: 1/3 portion of the nitrogen and full phosphorus and potash as basal at sowing and remaining N into equal splits at first and second irrigation. So with the applying of the same methods, in late sowing condition, the dose of the fertilizer 90 kg nitrogen per hectare is required, 60 kg phosphorus and 40 kg potash is required per hectare with the same applying methods. In rainfall condition, means where the cultivation is dependent on the rain situation, where the irrigation technologies are not found. So in that condition, the 125 kg per hectare, the seed rate is required, and the fertilizer dose around that 60, 30, and 20. 60 kg nitrogen, 30 kg phosphorus, and 20 kg potash per hectare is required. But here the sowing techniques, here the application techniques means applied at the time of sowing everything. And that same things are given that different zones, irrigated timely sown and irrigated late sown, the fertilizer doses will be same, okay, and there is very rare difference. So that difference also come after that checking of the pH and checking of the nutrient availability in your soil. Okay, it is because that is only taken for the idea. That means that doses are given here, fertilizer doses and time of application. So fertilizer doses means for the produce of that wheat in a 1 hectare land, that the amount will be removed by that crop. Okay, that type of things research soon. So that means, but it's not mean in every condition of soils you will apply that 120, 60, 40 ratio. Okay. That is a given generally average, which is taken nutrients from that soil. Mean that is the major nutrients which is takes from the soil by our crop. So that is generally one idea is given. So without the soil testing, don't prefer and don't recommend it. Don't apply that recommended dose. So first check how much availability in your soil, and after that minus from your recommended doses, and which is the remaining amount that should be only applied to you. So always remember, prefer that soil testing first. So in nutrient management, recommended doses of the fertilizer and NPK should be used. Nitrogen use efficiency is more when fertilizer is placed by drill. 1/3 nitrogen application at sowing and 2/3 at first node stage. Supplementing inorganic fertilization NPK with zinc and FYM increase the wheat yield. Application of potash is necessary as soil is getting depleted of potash content due to intensive cultivation. Micronutrient deficiency appears under light soils under intensive cropping, especially in rice wheat cropping system. In sulfur deficient soil, single superphosphate, COSA with 90 WDG, 10 kg per hectare, or gypsum 250 kg per hectare can be used. Zinc sulfate should be applied 25 kg per hectare. Once in rice wheat system, or 2 to 3 foliar spray of 0.5% zinc sulfate, whereas 21% zinc is found at 15 days after sowing. In manganese deficient soil, spray 0.5% manganese sulfate solution 2 to 4 days before first irrigation and 2 to 3 spray afterwards at weekly intervals, clear sunny days. So this is about nutrient management. And if we talk about that manure, say about 10 to 15 tons of well-rotted farmyard manure or compost should be applied 4 to 6 weeks before sowing and work well into that soil. And if nowadays the trend of the organic farming, okay, so in organic farming we are using just that FYM, compost, and to fulfill that requirement of the nutrients, generally use that manures and biofertilizers. And after that, some remaining amount we complete through that chemical fertilizers. So if we have to the biofertilizer, so sure we have to use the 100 kg seeds packets of PSB, okay, of PSB before sowing will improve the wheat nutrition as integrated nutrient management. If the wheat is sown after legumes or fallow, then 25% dose of nitrogen can be reduced. So after that management of the fertilizer, now the comes of the very important practice, water management. So generally we know that plant body is also around that 85 to 90% made by the water. And water is also takes participate in lot of metabolic activities of the plant. So that's why water is very important, not for only our lives, the plant also. So after that management of nutrients, the water management is very important practice for every crop. So in wheat, let's see that there is 6 irrigation stages are given. In which stages that water is required by the wheat crop. That 6 stages are crown root initiation, means CRI stage. After that, coloring stage, which is known as first node stage. After that, jointing stage. Fourth is boating stage, and 5th is milking stage, and 6th is duff stage. But here, given that tick marks 1, 2, 3, 4, 5, 6 irrigations, so let's understand that this chart for irrigation management. So how much irrigation you have available on the numbers, it will be depend. Suppose that you have only you are capable to give that only 1 irrigation to the crop. So the CRI means crown root initiation, that is very important stage where you should apply that irrigation. Because if you will not apply that water in CRI stage, so that stages it may reduce that production up to 20 to 30 quintal per hectare. Will not supposed to. So that crown root initiation, that is very important stage for the plant growth. Okay, because plant growth is started from that first stage is that. So if you have to that first irrigation, means only 1 irrigation is available. So give on that stage. After that 21 days after sowing. But you are capable to give that 2 irrigations in the duration of the crop. So first apply to 21 days after sowing, means CRI stage. Second, give to that boating stage. If you have that applied the 3 irrigation, means you can easily comfort with the 3 irrigations. So first irrigation stage CRI, you have to apply that. The second one in jointing phase, and third one in milking stage. If you have comfort with that 4 irrigation, so in first stage apply, after that coloring stage, third one jointing stage, and the 4th one milking stage. If you are capable to do 5 irrigations, So just leave that duff stage. In all stages you have to apply. And if you are comfort with that 6 irrigation, okay, so give that in all irrigations 1 light irrigation. But without check the moistures, don't apply that irrigation according to the chart. Okay, because according to the reason, according to the stage, and according to the rainfall, okay, we should always check how much moisture condition or what is the moisture condition of our soil. If moisture condition is if moisture is depleted in our soils, then we should apply that irrigation. If moisture is available around that 60%, 60 to 5%, okay, and up to 70%, so we should not apply to irrigation. That is suitable for our crop growth. So after that, water management, the weed management exercise is very important, because weed in generally India, weed is the reason of the 20 to 30% yield depletion in India. So that's why weed management, that is very important practice in our India. And also with the management of the weed, we can grow our crop and we can get that willing in it. So in weeds, some of the grasses groups, broadleaf weeds are found, both grassy and broadleaf weed are found. Okay. So if we talk about the grasses, so there is different types of grasses are found, which is the Avena species, and after that Ferris species, Polygon species, and Pova annua species. So different type of grasses given, and that grasses are found. If you talk about the broadleaf weeds, the Chenopodium species there, okay, Rumex species there, Medicago species are there, and Melilotus indica, and Parviflora, Solinum, okay, and Asphalius. So the different types of species of weeds are given, and that is affected in our crop. Also the both grassy and broadleaf weeds, okay. So in the front of the weeds, how can you control that? The methods of means application of herbicides is given, and what the dose should be taken. So dose is also given, and when you have to apply, so time of application in days after sowing is also given. Post emergence means after that growing the crop, means in the duration of the growing, okay, because after germination. So post emergence means after emergence. So 30 to 35 days after sowing. So when you will apply that herbicides, the time is also given. For that broadleaf weed also, so the herbicides are given here, and the time of application is also given. You can easily check with that list. So according to the find that weeds, which type of weed in your field is there, okay, broadleaf weeds, grasses there, and both grassy and broadleaves means both are there, okay. So you can control by using the different types of herbicides with the different doses and according to the given time of application. Okay, means when you should apply to that. But before that, applying the herbicides, because herbicide is the chemical, and we should not prefer the firstly chemical to control that anything. Okay, because now we want to that quality also. We also prefer our health first. So in that way, we have to prefer that organic cultivation and try to some different way to control of everything, because whatever that harmful things. So first we should try with that our cultural practices, our mechanical practices, or by the using that some bio control agents. Okay, and if we will not able to control by that any methods, then we will prefer that chemical control. So they are also given that cultural and preventive, okay, measures some. So cultural practices such as time and method of sowing, crop density and geometry, crop varieties, those method and time of fertilizer application, time and method of irrigation have pronounced effect on crop weed interference. Because you always heard about the crop weed competitions. So which things are required for growth of the crop? The same things are required for weed growth. So that all our practices are effective. So we have to keep that all practices on time, okay, because delay of the time of application in that practices or earlier, so that both of things are affected our crop growth with that weed. So the cultural practices, okay, we have to follow them according to the time. And next is the mechanical control. So it involves the removal of weeds by various tools, implements, including hand weeding and pulling also. So it is not feasible where weeds resemble morphologically to crop. Example, Phalaris minor, Avena, Ludoviciana, and before flowering in wheat. So also mechanical weed control becomes difficult in broadcast sown wheat. And however, mechanical control can be practiced effectively when wheat is sown on FIRBS, as this system facilitates tractor-mounted implements uses. So if we have to prefer that mechanical control or cultural practices, so we should adopt the sowing methods by that drilling methods or by that FIRB methods, which is more effective for that water conservation and to do that intercultural operation. And now next one, chemical control. See, we have already discussed the chemical control. It's also here given that chemical controls are the pre-emergence, post-emergence, what you should apply that, and both gradient broad leaves, which types of herbicides you should use, and how much amount is already given here. So you can study. Now the last thing is that from the crop harvesting, threshing, and storage means finally after control of weeds and completed that all practices of the cultivation, let's finally come on the point of the harvesting and threshing and storage. So harvesting and threshing methods, manual or mechanical, the both things are there, and storage depend on the moisture content, drying, and chemical used for storage best. So harvesting and threshing. So high yielding dwarf varieties of wheat should be harvested when the leaves and stems turn yellow and become fairly dry. Okay. So to avoid loss in yield, crops should be harvested before it is dead ripe. When harvest is not done in time, grain may be lost due to damage by rains, birds, insects, settling, and lodging. Timely harvesting ensures optimum grain quality and consumer acceptance. The right stage for harvesting is when there is about 25 to 30% moisture in grains. Harvesting is normally done when seeded age sickles by hand, bullock-driven reapers, and also used reapers are also used occasionally. Combines are also available, which can be harvesting. Threshing and winnowing wheat crop in a single operation after harvesting that crop by hand. It is dried and 3 to 4 days on the threshing floor, and then threshing is done by trampling bullocks or thresher attached to bullocks. Nowadays, power-driven stationary threshers are becoming more popular because these are easy in operation and hasten the process. So with that harvesting, threshing, and storage, our wheat cultivation is complete. But the one most important portion which is very affected our crop, and this the portion is plant protection. Plant protection from the disease and pest is only remaining. So that is the not part of the agronomical practices, but if we are as a farmer, we are as a student of agronomy, so we should also take the knowledge of plant protection, because the some basic knowledge we should have to protect our crop from this pest and diseases. But that is also major part of the pathology, so that's why we are not including in a crop. Okay, but the basic information. So we will complete that plant protection in another part, that wheat part 4. Until, keep watching, keep sharing, keep liking. So thank you for watching me, and keep watching. And we will meet very soon in next lecture with that wheat cultivation part 4 in plant protection. और तब तक के लिए आप देखते रहिए और हमारे साथ जुड़े रहिए। हम इसी तरह आपकी खेती की महत्वपूर्ण बातें लेके आते रहेंगे, और आपके कोर्स और सिलेबस सारी चीजों को हम यहाँ पर एक ही प्लेटफॉर्म में कंप्लीट भी करते रहेंगे। आपका बहुत बहुत धन्यवाद।